Hello and welcome. Today we're going to be going over parts 2, 3, and 4 of homework number 3. So my question says, what is the magnitude of the instantaneous velocity of a freely falling object 26 seconds after it is released from rest? Okay, so it wants to know the magnitude, which means we're going to give this answer without sign, and it wants to know the instantaneous velocity. So that could be considered VF if you want, or just the ending velocity or speed, and it falls for 26 seconds. And it's released from a position of rest. Okay, so with all of these things, it looks like VI is 0 meters per second. Our time is going to be 26 seconds. And our acceleration is a rounded value of 10 meters per second squared. This actually is so that you could just do a quick calculation in your head instead of having to drag out your calculator and punch in the numbers. All right, so there are two ways to do this. You can either use the formula VF equals VI plus AT and say, okay, my final velocity is equal to 0 plus 10 times 26, which would be 260 meters per second. The other way that you could do this is, oops, let me hit the undo button. I did not mean to erase everything. There we go. All right. The other way that you could do this is by making a table and just kind of thinking about this for a second. So let's see. I'm going to make a table and say, all right, no sticky keys, please. The other thing we can do is say, hey, if I have a particular time, what's my speed or what's my velocity? At time 0, my velocity is 0. Now, since it is increasing at 10 meters per second every second, after 1 second, the speed would be 10. After 2 seconds, the speed would be 20. After 3 seconds, the speed would be 30. And so you can see it's increasing by 10 each time. And so after 26 seconds, the speed would be 260. And so you can either get the formulas out and hammer it with the math and get your answer that way, or you can look and think about it and come to your answer that way. So two ways to sort of make your way through part number 2. All right. Now, part number 3. So let's write down that. So our final velocity is 260 meters per second. I'm going to write that down. So part number 2 for me is 260 meters per second. Now, part number 3 asks, what is the average speed during this 26-second interval? Well, if you have something that moves smoothly from 0 to 260, it turns out that the average is the midpoint. So the average speed of something that accelerates uniformly through a particular range is the midpoint. So in order to get the midpoint, we're going to add up the two endpoints and divide by 2. So 0 plus 260, and then divide by 2, all of which equals 130 meters per second. Right. And so there's part 3 at 130 meters per second, meaning the average velocity over that time period. So we have the beginning velocity of 0, the ending velocity of 260, and the average velocity of 130. Now let's consider question number 4, and I'm going to choose a more vivid pen color that maybe will be a little more visible. Great. So, so number 4 then says, how far will it fall? In other words, what is the displacement? So once again, there are two ways to do this. You can either say, well, gosh, if the average velocity was 130 and the time was 26 seconds, if it fell with an average of 130 for a time of 26 seconds, then we could just multiply 130 times 26 and get our answer. I'm not sure what that is and don't have my calculator with me, so I'll let you punch the numbers there at your desk. The other way is we could drag out the math and we can do the math this way. Delta D equals VIT plus 1/2 times 10 times 26 squared. All right, and of course 1/2 times 10 is 5, and so we'll end up with 5 times 26 squared, or 130 times 26, and those will give you the same thing, because 5 times 26 is 130, so you can see that it's 5 times 26 times 26, or 5 times 26 times 26. And so those answers will be the same. All right. I hope that that was helpful and that you understand a little more about how to work problems like this. Thanks so much and have a good day.